I'm going to walk you through what these three formulae mean and how to understand them, as well as looking at cash flow indexation on a timeline to better understand the intuition behind it. And then I'm going to go through a few examples to really put into practice the understanding that you would have developed in terms of nominal, monetary, and real values and yields. Okay, so first up, we have this lowercase ct that appears here. Lowercase ct is the nominal cash flow that occurs at time t. So the nominal cash flow is without the effect of inflation being accounted for. So we do not account for inflation. So I could say to you that in the future, I'm going to pay you at time whatever a nominal cash flow value of 1,000. Now, if I then go on to say that I'm going to link this to a particular index, then I'm indexing my cash flows, or I am linking them to some sort of inflationary measure. It could be your consumer price index, or maybe I'm linking it to the price of gold or something along those lines. But the amount that I initially state that is not being accounted for, that is not accounting for the price of gold or the CPI or whatever your indexed value is, that's not accounting for inflation. That's called the nominal value. Okay, and if I do make no mention of indexing cash flows, then you assume that nominal values are the actual values that are received. Now, if I say that I'm indexing my cash flows with respect to the consumer price index, for example, then what I'm meaning is that at a future date, whatever my consumer price index is, and relative to what it was now, I'm going to change my cash flow in the same proportion that my price index or my indexation value has changed. And this indexation value that we are going to be referring to is going to be Q of t. And Q of t is the indexed value at a particular point in time, which is t. Now, we know that ct, lowercase ct, is the nominal value. Now, uppercase ct, or capital CT, is the monetary value. And this is the nominal value that has been increased or decreased with respect to our inflation index. So for example, if our inflation index, our price index has increased, then our monetary value will be greater than our nominal value. And if it has decreased, then obviously our monetary value should be less than our nominal value. So we're linking it to a particular index, so it moves in line with that index. If the index increases, then the nominal value should increase too, and if it decreases, then the nominal value should also decrease. Okay, so the monetary value is essentially then that cash flow, what it's worth or what it's actually going to be at a particular point in time. So it's taking into account your index at that point in time. So it's in line with your index at that particular point t. Now, if we move on then from monetary cash flows to real cash flows, or uppercase RT, then how would we interpret this? Well, capital RT is the cash flow after we have accounted for inflation or removed the effects of inflation. So we are putting all our cash flows on our time value line. We're putting all our cash flows in terms of the same index. That's our goal with creating real values. So now we may have our particular monetary values that we're actually going to be receiving. And let's say those are at all these different points t on the timeline, wherever they do occur. And we've accounted for them and we've indexed the nominal values to become these monetary values. So we now have the actual amount we're receiving, but we want to know what they are really worth, what their real value is in terms of current day prices. And let's say current day prices is naught or t0, depending on where you are. Maybe they're the same date, but I'll get to what these mean in a moment. Then what I'm essentially saying here is that we need to move them back in terms of their price index or their Q index back to this particular point in time. All of the cash flows need to be indexed to the same point in time. Then we can compare the cash flows relative to each other without having the effects of our index clouding our judgment or affecting what these cash flows are worth relative to each other. Okay, so let's then look at this number line and look at exactly what it all means. So 0 over here is the issue date, and this timeline really refers to a bond, but not exclusively to a bond. So the issue date, or time 0, is when your bond is issued. This is when your company or your government that is initially issuing this bond to the public initially makes sale of this bond. So that's when the bond comes into existence. You might not purchase it at the issue date because you might purchase it on a secondary market, and therefore your purchase date would be T0, which would be a later date to your purchase to the issue date. But if you do purchase it at the initial issue date, then T0 and 0 is the exact same thing. Okay, so now what exactly is TL? TL is the date of the last known index at your purchase date, or at T0. So whenever you are purchasing this bond or this financial asset, at this purchase date, there might not have been an index value corrected to that particular date or released at that particular date, because after all, you don't have to buy your bond or whatever you're buying at the dates at which your indices are released. So if you're buying it at a date where your index is not current yet, or it's not accurate to that particular date, then you use your last known index, and the time of this last known index is TL. Okay, so T over here is obviously cash flow, the cash flow dates after purchase. And that's simple enough. I don't think it needs much explanation. But something that does is this lag that's appearing over here. So what exactly is this lag? Well, if you are wanting to index a particular cash flow so that you want to know the actual amount that you should receive on a date, your monetary value. Now you'll notice for monetary values, I have two equations over here, or two formulae. So the reason why I've put two is this is essentially a simplified version of this right-hand formula. It's just where the lag equals 0, or there's no time lag. So let's first understand this then, because then obviously you will be able to make sense of that. So first we need to understand what lag is. Okay, so at a particular date, you want to find out what your actual monetary cash flow is, the money in your hand that you're going to be receiving or paying, because you've set nominal amounts and you've said that it's linked to an index, but now you don't know what this index is going to be, but you still have to pay them an amount. And now, since it takes time for indices to be released and confirmed and all the logistics that go behind that, there's actually often a time lag whereby the point in time, let's call it X, and a point in time later where the index for X is confirmed or released. And the time difference between X and when you find out what the index was at X is known as your time lag. So if I explain that quickly on this small little timeline here, at this point in time X over here, we are supposed to have a correct index, Q of X. But it takes time for Q of X to be released, calculated, or confirmed. So it might be that Q of X is only released at this time point at a later date. Q of X plus lag is when Q of X is released. Okay, so the reason why we have then a lag is because we can't index our nominal cash flow that we were supposed to receive here with this Q of X because we don't know what it is. This is in the future. We're sitting over here at X and we want to find the exact amount of money that we're supposed to be receiving here at X, and it's important that we receive our money at X, but we don't know what to receive because we don't actually have this value Q of X. So we use Q of X minus lag. So that is a set value back from X, the time that it takes usually to release the indices. So essentially then you might say, okay, but then it's not accurate because I have an index that I'm using at this point of time that was before X, but I'm using it for a cash flow that's occurring at X, and that's not accurate because what happens if something happens between X minus lag and X? And yes, you are right, and that's why there are discrepancies that occur, but this is the best that we can do because we don't actually know anything at X. And we won't make it the last known date before X, which by the way might not be TL because this T might be over here and we're sitting at T or at X and our last known would then be there. So, but what I'm essentially trying to say here is we can't make it the last known at that particular point in time because what will essentially happen then is if there's inconsistencies and at another time point, your last known date was only 3 months before, but at X, your last known date was 7 months before. Now you are not taking into account the inflation relative to the actual time value difference that you should be taking into account. So what I'm meaning then is if you're moving from time naught to time x, so you want to increase your nominal value or move it relative to your index from a particular time naught to a particular time x or t, then it must move exactly t distance across. So if you want to use a lag, it has to be a consistent lag for all cash flows, because then you have a lag over there, and this time distance is your lag, and this time distance is your lag. So the distance then between those 2 points is still t. Okay, and that's important, as I said earlier, because if for this particular cash flow, it happened to be, your last known one happened to be 7 months before, but at a particular cash flow later in time, it happened to be 3 months before, now you're going to be using inconsistent distances in time. So this might not be t then. It might be, if you had your last known one was there, this was your last known cash flow before time t, but you need to index it to time naught, then you're moving it this amount of time, which is not actually the full length of t, because you're missing out that small gap over there. Okay, so I hope I've explained this timeline well enough, and what I'm going to do now is quickly explain now, once we know what all of these points in time mean, I'm going to explain these formulae again quickly after I've cleaned my screen, and then I'll move on to the few examples. All right, so capital C of t, just to recap, is our monetary value, lowercase c of t is our nominal value, and we know our nominal values of all the cash flows that are going to occur right at the issue date, because this is all confirmed, in advance at your issue date, your nominal values. But now your monetary values, they will link to inflation or a particular index. So what happens then is, for this cash flow t, we're supposed to move it t along, index it via t, but we don't actually know the particular index at time t, so in order to be consistent, we use the index at t minus lag, but remember, we must still move it a t distance along in time. So from 0 to t is a t distance along in time, but we've chosen a consistent lag, so we're going to be using the index at t minus lag for the cash flow that occurs at t. But now 0 to t minus lag is not t distance apart. So we have to actually index it from 0 minus lag to t minus lag, because t minus lag minus 0 minus lag is t distance apart as desired. Okay, and then you might ask me, okay, so why do we divide by q of 0 minus lag and multiply by q of t minus lag? Now, I like to think of this as we are dividing from where we are coming from, and we are multiplying by where we want to go. So if c of t is our nominal value that we've confirmed at time naught, but we're using a time lag, then we have to move it from time naught to time t. But in our case, we do that by dividing by the index that was at naught minus lag, and then we multiply it at t minus lag to move it along further t distance into the future. Okay, so then what is our real value? Why are we dividing by q of t, and why are we multiplying by q of t naught? So q of t is the index that occurs at time t. And notice that for our real values, we do not use a time lag. And why don't we use a time lag? Well, I like to think it's because for monetary values, we need to know the exact amount of money that you're going to be receiving. We can't delay this money because you are supposed to receive it at a particular point in time, but we don't have the index. So we make do with the next best, which is the index at lag distance in the past. But now for your real values and your real interest rates that you're going to be calculating, we want to know exactly, removing the effects of inflation, what your money value that you actually received is worth after you've removed these effects of your index. So we use the indices at the exact points in time. Okay, so why do we divide by q of t? Well, as I said before, we divide by where we are coming from, and we multiply by where we are going. So if our cash flow occurs at time t, then we must divide by the index at time t. And we want to know what this real value was at our purchase date, because this is what's important to us. We want to know our real value. We want to know our real yields. So we move to the purchase date. So we multiply by the index at q of t naught. All right, so I think we can move on to a few examples here. And by the way, if you struggle to understand anything from this video that I've said so far, please leave a comment in the comment section below. I'll try my best to attend to all of them. Okay, so here's our first question. Suppose that you invest 1,000 Rand at time 0, 2,000 Rand at time 2, 3,000 Rand at time 5, 9,700 Rand at time 10, and in return you receive 18,100 Rand at time 12. What real rate of interest have you earned if the values of the relevant index are 140, 130, 150, 200, and 170 at your respective time points? Okay, so the first step to do here is we need to calculate the real values. And now you may say to me, why on earth are we not calculating monetary values first here? Because I remember from these formulae, we had to go from nominal values, lowercase ct, to monetary values, and then we used monetary values to go to real values. But now you're telling me that we want to jump straight to real values. Now, the reason why is because these values that are invested at these particular points in time, they are our monetary values, because those are the exact amounts that we're investing. And we want to know, after we remove the effects of our index, what is our real rate of interest? Okay, so we are jumping straight now from these values, which are monetary values, to our real values. So first we need to calculate what the real values are. So let's go ahead and write here real values, and then at time 0 or time 0, so we have our cash flow is 1,000 Rand, and we're investing that. So it's coming out of our account minus 1,000, and we need to multiply that by the indices, the relevant indices. So first we divide by where it's coming from, and where's it coming from? Time 0. So Q of 0, and we need to multiply by where it's going. So where is it going? We want to move all these to the same point in time. We can choose that particular point in time, but I'm going to choose time 0. Okay, so we move that to Q of 0, and that becomes minus 1,000 times by 1, obviously, because those will cancel out. Now, at time 2, we had a cash flow of 2,000 Rand, and we invested it, so it's coming out of our bank account, so we have minus 2,000, and we are going from times 2, so we divide by Q of 2, and we multiply by the index to which we are moving towards, so that's Q of 0. And what is Q of 0? So Q of 0 is 140, and Q of 2 is 130, and if we solve that, we should get negative 2,153.846 with some decimals following that. And we're going to follow the same process for time 5, 10, and 12, but I'm not going to waste your time, so I'll quickly fill that in. Okay, so let me quickly walk you through what I've done here. So for the cash flow at time 5, we had 3,000 Rand, which was an outflow, so we have the negative. We are multiplying by Q0 over Q5. So we divide by Q5 because that's where we are coming from, and we are multiplying by Q0 because that's where we are going. And the relevant indices for Q5 is 150 and 140 for Q0, as you can see here. We calculate that and we get negative 2,800. Now the same applies for time 10, where we have a 9,700 Rand cash outflow because we are investing this money, and we are moving from time 10 to time 0, and the index at time 10 is 200, and the index at time 0 is 140, and we solve that and we get negative 6,790. Now at time 12, we receive 18,100 Rand, so that is a positive cash flow or cash inflow, and we are multiplying by Q0 and dividing by Q12. So we divide by Q12, that's where we're coming from, multiply by Q0, that's where we're going. Okay, so if we do that with the relevant indices, 170 and 140, we get this number over here. Okay, and now you might say to me, okay, how is it possible that our indices don't increase all the time? How come they go from 140 to 130, and then they start increasing all the way to 200, and then they decrease again to 170 at time 12? And it's because you don't actually know what the underlying asset or certain thing that this index is representing. You don't know how it moves in time and how its prices and demands move. So we're linking it to this index, and because we don't know exactly how it's going to move, we don't know what the relevant indices are. So we can't use a set rate or a set periodic, evenly spaced increasing value for the index. We use the actual indices that occur. So that may even be where the index decreases at time 12 and increases before that and has another decrease randomly at this time point. So that's essentially why it may seem random. Okay, so we have the real values, but we were asked for the real rate of interest. So if we're calculating a real rate of interest and we have the real values, we have to set up a time value equation. So how do we do that? So we have our net present value equal to 0. So what is the net present value? So net present value is something that I probably expect you to know if you're doing this section in financial maths, but just briefly, your net present value is your present value of your expenses should be equal to your present value of your income. So present value of income minus present value of your expenses, your inflows minus your outflows at a particular point in time, that should equal to 0. That's your net present value. Okay, so what is our net present value? So at time 0, we have this real value. And at time 2, we have this real value. So that's minus 2153.846. And we are discounting this by the real interest rate or the real yield by 2 periods because it occurred at time 2. And then this 3,000 Rand monetary value is negative 2,800 Rand real. And we discount that by the real rate of interest by 5 points in time, so minus 5. We know that occurred at time 5. And then we do a similar thing for the real value minus 6,790, which occurred at time 10. So we got to move that back 10 points in time. So I chose time 0 to be where I'm moving all my cash flows to. So I didn't actually have to discount 1,000 because it occurred at time 0. But the cash flow that occurred at time 2, its real value, I have to discount by 2 time periods to get back to time 0. And 2,800, that real value I had to discount by 5 periods, and the 6,790 by 10 periods. And then we are adding, this is our inflow, 14,905.882, and that goes back by 12 time periods. And this left-hand side should equal to 0 because this left-hand side represents our net present value. Okay, so the reason why we have our IR in this equation is because we have our real values. So our real values discounted, when we discount them and we want to get a net present value equal to 0, we are discounting them with our real yield or our real rate of interest that we've earned. Okay, so if you go ahead then and solve this equation for IR, you will find the real yield. And that should give you an answer of 2.9247%. Now, I'm not going to go through exactly how you should calculate this real yield because it can be quite complicated and that's a topic for another video, but I'll say that you can do it in a few different ways. You could do it with interpolation. You could do it with your financial calculator if you have one. You could do it with Excel and maybe 1 or 2 other ways. For example, you could substitute in a variable for 1 plus IR to the negative 1 and then solve a polynomial, which I assume would be quite difficult because it'll be to the 12th degree, but that is something also that you could do. So there's a lot of ways you could solve for IR, but that's not really the point of the video. Okay, so we have found the real rate of interest. So let's move on to the next question. So a 3-year index-linked security is issued at time 0. The security pays nominal coupons of 4% annually in arrears and is redeemed at par. The coupons and capital payment are inflated by reference to the inflation index value 8 months before the payment is made. The inflation index value 8 months before issue was 110. So this is minus 812. Our index value was at 110. Now the reason why I write this in is because you might come to a point later while you're answering this question where you need that index or that time value, but you don't see it in the table. And then you automatically assume you don't have it, but it was hidden in this information. So that might just make it easier for you. And then the table below shows the index values. Yes, we know that. And then calculate the real yield if the price of the stock is 100 Rand. Okay, so first let's get a grasp with when cash flows are occurring and what their nominal values are. So if we have a timeline over here, we know that this index-linked security is a 3-year security. So obviously it has a time period of 3 years. Okay, and we are going to be buying the security for 100 Rand. So we have minus 100 at time 0. And at these points in time, we will receive coupon payments. And at time 3, we will also receive a redemption payment. Okay, so what are our coupon payments? So the coupon payments are 4% annually in arrears. So that's 4% of 100, which is 4. And at time 3, we shall also receive 4. But we also, on top of that, we receive the initial price of the stock. Let's redeem that par, so that's plus 100. So we just have plus 104. So we have the nominal values over here. Okay, so let's actually draw a table. I'll draw it up quickly and then I'll get to the rest. Okay, so I've inserted the nominal values and now I'm going to calculate the monetary values. So monetary values, as you should remember, is CT, capital CT, is equal to lowercase ct, the nominal value, times by Q of T minus lag over Q of naught minus lag. All right. So at time 1, we are going to multiply our nominal value by the index that occurs at naught minus lag. So naught minus lag is actually this point over here. And the reason why is because it says are inflated by reference to the inflation index value 8 months before the payment is made. So 8 months means that our lag is 8 months. So 8 months before time 0 is negative 8 over 12. So that is dividing by 110. And we are taking that to the point in time 4 months before t, and t in this case is 1. So 4 months before 12 over 12, sorry, that's 8 months before 12 over 12 is 4 over 12. And our index is 115. And that gives us a monetary value of 4.18, and the 1 and the 8 are recurring. Okay, at time 2, our nominal value of 4, we must still divide by Q naught minus lag, which is 110. Of course, it's still the same value. And we multiply by Q of T minus lag, but except T here is 2. So 2 minus 8 over 12 is 1 and 4/12. And the relevant index is 118. And if we calculate that, we get 4.291. And at time 3, our nominal value of 104, in order to get our monetary value, we still divide by 110, which is Q of naught minus lag, and we multiply by 3 minus lag, which is 2 and 4/12, and the relevant index is 122, and that gives us a value of 115.345. Okay, so now let's go ahead and calculate these real values. So your real values are then your monetary values multiplied by, so we divide by where we are coming from, so that's Q of T, and we multiply by where we are going, which is Q of T naught, or the index at your purchase date. So here we take 4.18 and we multiply that by, so Q of T naught is going to be the same as Q of naught, which is 112, and Q of T is Q of 1, which is the index corresponding to this time point, which is 116. So we divide by 116 and we multiply by 112 because we are going from the index at point 1 to the index at point 0. And that gives us a value of 4.0376. And if I do the same for these two, I should get 4.291. Divide by where it's coming from, Q of T, or Q of 2, which is 119, multiply by where it's going, Q of naught, 112. If I calculate that, I get 4.0385, and then this 115.345. If I calculate the real value, I've got to divide by the index at time 3, which is 125, and I multiply by the index at purchase date, which is 112, and I get the final real value of 103.35. Okay, so I have all my real values, and I was asked to calculate the real yield. Okay, so once again, I have to set up an equation of value. So initially, I'm going to outlay 100 Rand to buy the security, and that is at time 0. So that's minus 100. Now at time 1, I outlay this amount. So let me quickly write up the equation of value, and I'll explain it after. All right, so I've taken all these real values, I've put them into my equation, which is my net present value equal to 0, and I have discounted them using my real yield. So because this real value, the corresponding monetary value occurred at time 1, I discount it by 1 period, and likewise this real value I discount by 2 periods, and this real value I discount by 3 periods. Okay, and this is my cash outflow because I initially buy the security, and these are the cash inflows that I receive from the security, which is my coupons and redemption payments. Okay, so now, once again, all you have to do is solve for IR, which should give you a real yield of 3.82%. Now, just note that at this point in time, you may or may not be able to solve for IR, as in you may not be able to, in terms of just your skill set, you might still have to learn interpolation or how to use your financial calculator, Microsoft Excel, or something along those lines. So don't stress if you can't actually calculate your real yield just yet. Just you should know how to get to this equation. All right, so I hope this video made sense to you. I do think it's one of the more difficult topics in financial maths for actuarial science, but if you found it interesting or useful, please do leave it a like and subscribe to the channel. And if you found anything confusing, please do leave a comment in the comment section down below, and I'll do my best to attend to it. Thank you for watching.